In this video, we are continuing our discussion on multicollinearity. In the last video, I have already talked about ridge regression as one way of dealing with multicollinearity. In this video, we shall take a closer look at this technique as well as a related technique. Now, the way we had introduced this technique in the last video was like an ad hoc way, where I just said that your x prime x was close to singularity, so remedy that by simply adding a diagonal entry to each of these terms. So each of the diagonal you add some non-negative quantity, some strictly positive quantity basically, such that its inverse exists, and you work with this. And then I said that these have certain advantages. Now it is possible to look at ridge regression in a more systematic way. For example, when we looked at our usual least square technique, we could say that it is actually maximum likelihood estimation under a certain model. So instead of just presenting it as a way of minimizing the norm square, I can say that it comes from a statistical assumption. We can do the same thing in case of ridge regression also. In this case, we will put it as a Bayesian problem. So what we already had, that statistical assumption that we have already put was y follows multivariate normal x beta sigma square I. It is same as our Gauss-Markov model. I have not written it in terms of epsilons. I have just written it as a distribution of my observed data y. Now, I will just change this slightly. I will say that beta is also random because I am going into the Bayesian world. So I will say that this is my model. So whatever I had earlier now becomes my model. But since beta is random, I will say given beta, the distribution of y is whatever we have seen earlier. But now that beta is a random quantity, I need to specify a distribution for beta as well, and I do that by specifying a prior on beta, which itself is a Gaussian distribution, Gaussian with dimension p, mean 0 and variance some tau square I. Now if you carry out Bayesian procedure, in that case you will see that the posterior mean or the posterior mode, both of them will be the same, for beta will be ridge regression estimator. Now in the earlier formulation, the ad hoc formulation, I had a lambda. Here I have a tau square and they are related. For a given value of tau square, you will get a corresponding value of lambda. That is, if you use some particular value of tau square, whatever Bayes estimator you will get will be of the form that beta hat lambda for a suitable value of lambda. So lambda and tau square are related. They are both tuning parameters. In this formulation, the tuning parameter is tau square. In that formulation, the tuning parameter was lambda. Now, I am not going to go into the details of this. It is pretty straightforward. Just do the computation and you will see why these two things are actually equivalent.